So for these real world situations, since we're dealing with exponential functions, you need to find the constant ratio. Remember, the constant ratio is the value that you multiply to get the next output. So you take the previous output, multiply it by the constant ratio to get the next output. So we're just going to look this first situation. We discussed this in class, but basically it says in this first paragraph, scientists are studying bacteria and the population grows at an exponential rate. So we use an exponential function. So it says one bacterium can reproduce asexually by splitting into two identical bacteria. Let's say we have a petri dish full of bacteria that reproduces in this manner every day. That is, each bacterium splits into two bacteria once per day. Let P of D be the population of bacteria on day D. Some important information. Here it tells us the input is number of days and the output is the population of bacteria. Then in this previous sentence, it tells us, that each bacterium splits into two every day. So once a day, it splits into two. So let's go through each of these and answer each of these questions. First, it asks, or it says, assume the petri dish started off with 1,000 bacteria. Represent this in function notation. So if it says started off, you think, okay, how many days is that? What's the input? Well, when you start off, no days have passed. The starting point would be day 0. So I say P of 0. And let's see, what's the output for that? Well, it tells us right here, it's 1,000 bacteria. Notice we can use function notation without knowing the symbolic representation. This simply says on day 0, the starting point, the bacteria is 1,000. Next, what will the population be on day 1, day 2, and day 3? Write your answers using function notation. Okay, day 1, that's P of 1. We multiply the output by 2, so we get 2,000. On day 2, it's P of 2. Again, we multiply by 2, since the population doubles. Then on the third day, once again, the population doubles again to 8,000. That's what we have to write for that. So as we can see, function notation, we can express very succinctly the population on the first 3 days. Next, it asks, determine the constant ratio of P of D and use it to briefly explain why P of D is an exponential function. Okay, since we multiply by 2 each time, that is our constant ratio. The constant ratio of P of D is 2. And then we can say P of D is an exponential function because we multiply each output by 2 in order to get the next output. Right? The definition of what makes it exponential is that we multiply by our constant ratio, which is 2. All right, the last question, does P and D exhibit exponential growth or decay? Provide a brief explanation to justify your conclusion. Refer to the constant ratio. Okay, so we could say it that P of D is exponential growth because the outputs are increasing. That's one way to say it. However, we did not refer to the constant ratio. So if we want to refer to the constant ratio, we could say also it is exponential growth because the constant ratio is greater than 0, than 1. Remember, if it's less than 1, if it's between 0 and 1, it's decay. If it's greater than 1, it's exponential growth. All right, so now I think we understand this function better and this situation with the bacteria. So for the rest of the questions, there's different situations. All of them, you will have to figure out the constant ratio and answer some other questions. So please do your best with that. Please ask if you have any questions on this assignment, like how to find a constant ratio. The last two might be a bit more challenging, but we will go over number 4 in class.